Dear student, welcome to my channel. Topic of this video is modular arithmetic. Now let us start. Two integers a and b are congruent modulo to n. It means that the difference between the a and b is multiple of n. Now we will see the example to understand. That is when a and b leave the same remainder when they are divided by n. Now we will see the first example. 17 is congruent to 5 mod 3. It indicates that if we take the difference between 17 and 5, which is multiple of 3, so 17 minus 5 is equal to 10, and which is multiple of 3, that is 4 into 3 is equal to 12. Now when we take 17 mod 3 and 5 mod 3, they are equal, that is 17 mod 3 and 5 mod 3, it is equal to 2, and it can be also represented as 17 is equal to 3 into 4 plus 5. Now take the second example. 184 and 51, they are congruent to modulo 19. So if we take the difference between 184 and 51, which is equal to 133, and it is multiple of 19, then if we take 184 mod 19 equal to 51 mod 19, and it can be also represented as 184 is equal to 19 into 9 plus 13. Now we'll see the last example. 121 is equal to 13 into 9 plus 4. So we can represent the congruent modulo, that is 121 is equal to 4 mod 13. So it indicates that when we subtract 121 minus 4, because this is nothing but remainder, so 120 minus 4, it should be multiple of 13, and when we take 121 mod 13 or 4 mod equal to 4 mod 13. Key properties of modular arithmetic operation. A plus b mod n. So either we can do the addition of a plus b and then we can take the mod n, or you do first a mod n, b mod n, and their entire answer is again with the mod n. Only we require to take care that our answer should be lie between 0 to n minus 1, because this is a mod n. For subtraction, either we can do a minus b mod n or a mod n minus b mod n. We are adding plus n and then entire mod n. For multiplication, a into b mod n, either we can solve directly like this, or a mod n, b mod n, and their entire mod n. Fourth property is exponential property, and this property we are going to use extensively in cryptography. That is a raised to b mod n is equal to a mod n raised to b mod n. So when we solve the example, you will get clear idea that how to use this exponential property. So these are the some of the exercises. Total 25 exercises are there. I have tried 15 exercises, remaining you try at your side. First example is 3 raised to 25 mod 5. So first we will deal with the 3 mod 5. 3 mod 5 is 3, 3 square mod 5 is 4, 3 cube mod 5 is 2, then 3 raised to mod 5 is 1. So when we get the answer which is a small number, for example it may be 1, 2 up to 3, manageable, we stop the procedure. Now here this 24 we can adjust as, now here we are getting 3 raised to 4 mod 5 is equal to 1. So 4 into 6 is 24. So 3 raised to 4 mod 5 raised to 6. So we are adding, so 4 into 6 is 24. Only 1 is remaining, and that is nothing but 3 mod 5. So we will multiply, and again this is nothing but again mod 5. That is we are using the multiplication property. So this answer is 1 raised to 6. This answer is 3. So we multiply, again we will take the mod 5, and the answer is 3. So in this way we require to solve the problem. Now we move to the next problem. 4 raised to 34 mod 7. First we will try with the first number, then square, cube. Now here we are getting the minimum number. So here we require to do trial and error to get the minimum value, maybe 1, 2, 3, depend on our this exponential factor. So now here we are getting 1. So 34 is there. So 3 into 11 is 33. So 4 raised to 3 mod 7 raised to 11, 33. We require one more, 4 mod 7, and their entire mod 7. So this is 1 raised to 11. This is 4. 4 mod 7 is, sorry, this is 4 mod 7, and this 4 mod 7 is 4. Next is 5 raised to 48 mod 11. First we start with the first number, then second number, third number, fourth number, fifth number, and with fifth number we are getting the value 1. So here we require 48, and this is the 5. Then 9 5s are 45, so this is nothing but 5 raised to 5 mod 11 raised to 9. Now 45 already we counted, so only 3 are remaining, so 5 raised to 3 mod 11. This answer is 1 and this answer is 4, so 4 mod 11 is 4. Next is 6 raised to 29 mod 4 mod 8, 6 mod 8 6, 6 square mod 8 4, 6 cube mod 8 0. Now here the important observation is that when 6 cube mod 8 is equal to 0, now we require to arrange the 29. We can arrange the 29 as 9 into 3 27 plus 6 square mod 8 mod 8. Now this answer is 0 raised to 9 is 1 and 6 square mod 8 is 4, 4 mod 8. 0 raised to 9 is 0, sorry it is not 1, 0 raised to 9 is 0, so 0 into 4, so 0 mod 8 is again 0. Seven raised to 43 mod 9. First we try with 7, then 7 square, then 7 cube. Here we are getting the one answer, so 14 3s are 42 and 1 is 7 mod 9, and we will combine the answer by using multiplication property and we are getting the 7 answer. Next is, now see this example carefully. Here we will try for values, but we are not getting the small number, so here we may stop for this value 2 mod 13. Now 2 raised to or here we can stop for this value also, so here this value becomes very large, so we can get the solution here also. So 2 raised to 4, now it is 50, so 4 12s are 48, so 2 are remaining, so 2 square mod 13 mod 13. Now 2 raised to 4 mod 13, it is 3, and 3 raised to 12, so 3 raised to 12 4 mod 13 our is answer, because this is 4. 2 raised to square mod 14 is 4, so 4 mod 13. Now we require to calculate 3 raised to 12, so we again calculate as 3 raised to 12 mod 13, then 3 mod 13, 9 mod 13, that is we subsplit the problem again, 27 mod 13, and here we will get the one answer. So again we will get this as 3 square raised to 4, this our 4 mod 13, and this answer is 1, so again we are getting here 1 and 4, so 4 mod 13 is equal to 4. For some problems we are getting the answer in which the repetition numbers are 0, 91 91 91, so here we are getting the same answer. For 9 mod 10 we are getting 9, in 9 square mod 10 we are getting the answer 1, so 1 stop here. But in some of the problems we are getting the frequent particular intervals we are getting. Now here we are getting the one answer, we stop here, so it is 15 to the 30, which will come as 1, and this one is remaining, that is nothing but 9 mod 10, and our answer is 9. Here we are getting the frequency for example number 12, 8 mod 12, when the number is odd we are getting the 8 value, when the number is even, that is number power is even, we are getting the even, when the number power is odd we are getting the 8 answer, when the number power is even we are getting the 4. So this continuous frequency remains. So as 47 is an odd number, so our answer is 8. Or we can directly try this method also, 11 4s are 44 and 3 is remaining, and we will get the 8 answer. Now 10 raised to 26 mod 15, here for every number we are getting the answer 10, so we try for few numbers and after that we can conclude that for 10 raised to 26 it is also mod 15. For 11 raised to 37 we try for few numbers, when one get, our solution becomes very simple and we can do the calculation. So 12 3s are 36 plus 1, now here again we are getting this 4, 12 13 raised to 4 mod 16 1, so 9 4s are 36, so we are getting finally answer 1. So sometimes we require to try with a large number, so here 12, then 14 14 square, then at 14 raised to 7 we are getting this 3, so we stop here and we can get the calculation here also. In this example for the first number we are getting the 15, but After that, if for every number we are getting the answer 9, so we will try some few numbers, and if we are getting the same answer, we can make the conclusion that it will comes as a 9, or in between we can take their combination with respect to particular range number, that is power number, and we can make the calculation also. Here again, when 1 is there, we stop here, but sometimes for 4 also we can stop the procedure and we can do, but again we require to do the intermediate calculation. Now here again we are getting the frequency, that is pattern 26 16 26 16. So when the number is even, we are getting the that is number is even, that is exponential power is even, we are getting the 16. So 40 is even, so we can write down the answer 40. So I have tried the 15 problems, so remaining problems you can solve, because these problems are required solving the cryptographic problems.